In this video, we're going to do some guided exam question practice on the question 6 that came up on our 2022 mock paper. Now, this question was answered particularly poorly, so it's about your general understanding of using the periodic table in different ways. So what we're going to do is we're going to begin by doing a quick recap of the important concepts here, and then you can have another go at the question. Okay, so we're going to have a quick recap of it. The first thing to note is that any particular element here has its own box on the periodic table. So say, for example, hydrogen, its box is here that I'm drawing in green. Oxygen is this box over here that I'm also drawing in green. So I'm just going to pick oxygen, and out at the side, we're going to just redraw that. So here is the tile for oxygen, and these are the things we will find in that tile. First of all, we will find the element's symbol like this. Oh, we've looked at this in a previous question on this mock, so this here is the symbol, but there's two other important things here as well. There are two numbers, so every element you see here has two numbers, so say here and here. So every element has two numbers, and for oxygen, those numbers happen to be 8, and the second number is 16. Now, all the elements have different numbers in them, so only oxygen has the numbers 8 and 16, and one of the numbers is always bigger and one of them is smaller. So say, for example, this number here on oxygen is 8. That's the smaller number because it's smaller than the second number, which is 16. And all elements will have this, a bigger number and a smaller number. Now, these numbers tell us different things and they have different names. So first of all, this here we'll say is the smaller number, and this one here is obviously then this is bigger than 8, so this is the bigger number. Now for this question, we really were focusing on this smaller number here. The name of this is called the atomic number. This is called the atomic number. We can get a few pieces of information from this atomic number. What the atomic number tells us is it tells us the number of protons that an element has in its nucleus, number of protons. Now, if this says 8 here, well, then that means that there are 8 positively charged protons in the nucleus of every oxygen atom. So there they are, 1, 2, 3, 4, 1, 2, 3, 4. So there will be 8 protons in an atom of oxygen. Now, what we've learned about before as well is that in an atom, the overall charge is always 0. So that means that we have to have the same number of negative electrons to balance this out. So the number has to be the same, which means we need to have 1, 2, 3, 4, 5, 6, 7, and 8. So technically, the atomic number, this number here, can tell us the number of protons or the number of electrons that an atom has. So 8 protons, 8 electrons. And they have to be the same so that they balance out charges. And overall, the atom will be neutral, has no charge overall because of this. Has a certain amount of protons and it has the same amount of electrons. Just as an aside, the bigger number is known as the mass number. The mass number. And what that gives us about is information about all of the total mass of the atom. And the particles that contribute to the mass of the atom are the protons and the neutrons. Now, we already know from the atomic number that oxygen has 8 protons, 1, 2, 3, 4, 5, 6, 7, and 8. We also know that each proton has a mass of 1, which means this is a total mass so far of 8. Now, there must be 8 more because look, the mass is 16. The other thing that gives mass to the atoms are neutrons. I'm going to write a 0 here because they have no charge. So each of these blue zeros represents a neutron. 1, 2, 3, 4, 1, 2, 3, 4. And altogether, this is a total of 8 plus 8, 16. So this is where the mass number comes from. Okay, so quick recap then. What does the atomic number tell us? Atomic number is the smaller number and it tells us the number of protons or the number of electrons that an atom has. They always have to be equal to each other. The bigger number is the mass number and it tells us the total mass of the atom and what contributes to the mass. The protons do, and so do the neutrons. Each proton and neutron has a mass of 1, which means we have to have 16 particles here altogether. We have 8 protons, so the other 8 must be neutrons. All right, so that's a lot of information there straight away. The next thing is we're going to go to our table and we're going to have a look at some other parts of the table. So I'm just going to rub out what I've done here quickly, and I'm going to rub out the green boxes. And now what I'm going to do is I'm going to draw a square rectangle around some elements. So you see here in pink, I am highlighting what we call a vertical column. This is a vertical column. And A vertical column on the periodic table is called a group. And elements are in groups because they have similar chemical properties. And the reason why they have similar chemical properties is because they all have the same number of electrons in their outer shell. So each of these vertical columns, say that one, and then this one, and then we could skip all the middle bit, and we're going to go over here. All this middle bit where it drops down, you can forget about that. And we go over here. So we're going to just ignore all this stuff for a second, and you see all of these vertical columns. These vertical columns are called groups, G-R-O-U-P-S, groups. And this is group 1, 2, and you're going to skip all this stuff then. This is group 3, 4, 5, 6, 7, and 8. And what the group number tells us is it tells us the number of electrons in the outer shell of the atoms of that group. That's a little shortcut. It's a very important shortcut. So say we look at the elements of group 1. Well, what we will find is that they all have 1 electron in their outer shell. So say, for example, hydrogen has just 1 electron. Well, it's got 1 electron in its outer shell. Lithium has 3 electrons. It's got 2 electrons in the first shell like this, and you will have learned how to draw these atoms. And again, it's got 1 electron in its outer shell. Sodium, sodium is the next one, Na, has 11 electrons altogether, 2 in the first shell, 8 in the second shell. I'm not going to fill it in, there's 8 there, and there's 1 left over for the third shell. Again, the pattern here is that whatever this number is up here, that is the number of electrons in the outer shell. So the number of electrons in the outer shell. This is called the group number. Number of electrons in outer shell. Now, if you didn't remember that, it's probably a good idea to make a note of it and just remind yourselves of that. That's the group number. Okay, so for example, I'm going to get you to think about this, speak your answer out to the screen when I ask you to. How many electrons would oxygen have in its outer shell? So look for oxygen and speak its number out to the screen. What do you think? Okay, I'm hoping that you said 6, because here is oxygen. It's over here, and it's in group 6. So that means 6 electrons in the outer shell. Now, it's got more than 6 altogether. It's got 8 electrons. So it's got 6 electrons in the outer shell. That's what the group number tells us. Outer shell. All right, we're going to now highlight some more elements. So I'm going to now highlight in blue some more groups of elements. So here I've got horizontal rows. So these blue rectangles, this time I'm showing horizontal rows of elements. And we can label horizontal rows. This is the top row or the first row, then this is the second, third, fourth, and fifth, and so on. Now, generally, we don't need to go much further than that. But what these numbers will tell us is the total number of shells. So say, for example, hydrogen and helium. Well, these have only 1 shell. They've got 1 or 2 electrons, and they both go into the first shell. Look at hydrogen here, it's got 1 shell. Here's lithium, look at lithium. Lithium, it says, has 2 shells. Well, let's check. There's lithium, there's the first shell, and there's the second shell. Yep, so it's got 2 shells. Here's sodium, there's 1, 2, 3 shells, and that means its period number is 3. So it's in period 3, which tells you, as a shortcut, is that it has 3 shells of electrons. Here would be the fourth. All the elements in this row here would have 4 shells of electrons in total, and all the elements in this one would have 5 shells of electrons in total. So what I want you to do is I want you to look for the element chlorine, and I want you to tell me how many shells of electrons it has. So speak your answer to the screen now. Okay, here's chlorine if you didn't find it. Speak your answer to the screen. How many shells of electrons? Okay, you should have said 3. And the reason for that is because its period number is 3. It's in period 3, got 3 shells of electrons. How many electrons has chlorine got in the outer shell? There it is again. Okay, so I'm hoping that you were thinking 7, because it's in group 7. Group 7, period 3. So 3 shells of electrons, and the outer shell has 7 electrons. Quite a lot of things there. Just recap the rules for drawing the atoms. What's the rule? 2 electrons in the first shell. In the first shell is the rule, that's the max in first shell. Once you fill the first shell, then you go to the second shell, which can hold a maximum of 8 electrons. When that's fully, go to the third shell, which can hold a maximum of 8 electrons. Those are the rules. Okay, I think you guys are ready to have a go at the question again now. So what I want you to do is I want you to pause the video, and I want you to take a look, not just yet, actually we're going to quickly read it here. It says the passage below relates the periodic table and the prediction of information relating to the structure of the atom. So this is a skill. It's a way you can use the periodic table to give you information about the atoms of the element. It says 5 words are missing from the passage. You may refer to page 79 of the formula and log tables. That's just this picture of a periodic table, and you should always use that during the exam. It says you can refer to page 79 of the formula tables and booklets when answering this question. Here are the missing words. So there are 5 blanks, so I think we're probably going to use each word once, but still just make sure it's logical. When you write in the word, make sure it makes sense, okay? So what we're going to do is we're going to get to pause the video and write down the 4 sentences, but fill in the missing words. It's a good idea to cross one off when you've used it. So pause the video and do this now. Okay, so you should only be playing if you've really had a go at this. And you've really read back over your sentences and see, do they make sense? Read them with the word in it and make sure that sounds silly, okay? Now, this question seems really easy because it looks like you just fill in 5 blanks. But the problem is if you put one of them in the wrong place, it's more likely you're going to put them all in the wrong place and lose all the marks. There was 3 lines going for each correctly placed word for a total of 15 marks, okay? So this is how it broke down. It says the number of protons in the nucleus of an atom is called the something number. The number of protons. We go back over here. What did we say here? Well, here's the protons. And if we want to work out how many there are, we refer to this guy. The atomic number tells us the number of protons. So here we got to go back up and let's use that word. Look here, we're going to use atomic here. Call it atomic number. And if you did that, well done, you got it right. Give yourselves 3 marks. Right, then it says in the periodic table, the something number can be used to predict the number of electrons that are present in the something shell or orbital of an atom. So we have 2 words to use here. In the periodic table, the something number can be used to predict the number of electrons that are present in the, okay, so that refers to the red columns here. Okay, so this is what we call the group number, 1, 2, 3, 4, 5, and so on. And it tells us the number of electrons in the outer shell of electrons. Let's go back here and find those things. So it says in the periodic table, I would say the group number. So the group number can be used to predict the number of electrons that are present in the outermost shell. Outermost shell of an atom. The next one, okay, so again, if you got some of them wrong, fix them and then see can you figure out the last 2. Okay, so you have another chance to pause and fix these now. Okay, so it says here in the periodic table, the something number can be used to predict the total number of shells or orbits that surround the nucleus of an atom. We go back over here, that's what we said was going on here. So we counted the shells of electrons. We said this here has 1 shell. This element here had 2 shells. And this element here had 3 shells at the bottom. Now, obviously, hydrogen is in this first row. Lithium is in the second row. So this number here is 2, and it's got 2 shells. This number here is 3. They would all have 3 shells. So this is what we call the period number. So each of these horizontal rows is a period. So going back here, hopefully you've had a go at this. In the periodic table, the period number tells us can be used to predict the total number of shells that surround an atom. And then last of all, we're left with the innermost shell, or the inner shell or orbit can contain a maximum of 2 electrons. And that's what we were doing over here. We said 2 electrons in the first shell. Here, look, this is what we wrote. 2 electrons in the first shell, then 8 in the second, and 8 in the third, and so on. And I would suggest you go back to your notes and just double check that you have all this information. So it says the innermost shell can contain a maximum of 2 electrons. All right, guys, that is that question. Like I said, it wasn't answered very well in the mocks. So it was something where we needed a little bit of extra revision as we were going over the question, rather than me just let you guys have another go at it. It was very clear to me that you were missing some of that key information. So hopefully that's cleared up a few things about how we can use the periodic table. It's a very valuable and very useful tool. But if you don't know how to use it, then it's not really much good to you. So lots of different shortcuts and different ways of getting information from the periodic table. All right, guys, that is question 6. We'll see you in the next video. If you found this helpful, do give the video a like. It might help other students to find it from other schools who might be struggling with this stuff. All right, guys, that's it. Thank you. Bye-bye.